I'm Brad Lamphere. I'm a postdoc from North Carolina State University on the Fiber Project, and we're out here tonight on the Kaiwal River, which is one of our focal streams, to catch Rivulus hardeye, which is the native fish that was already present in these streams before we ever set foot out here. And the reason we're out here is this Fiber Project has a lot of parts to it, and the big idea, though, is to see how guppies are affected by the environment, switching from high predation to low predation, which is what this is, since there's no other fish here, except for Rivulus. And also to see how the environment affects the guppies, I already said that, and how the guppies change the environment, and in turn you get a feedback between the two. Well, one part of the environment that we're out here to get tonight is Rivulus hardeye. Well, the reason Rivulus are already out here when other fish can't make it is that they're unusually good at dispersing across land, believe it or not. Rivulus is a killifish, and they're exceptionally tolerant to oxygen stress. And so they're willing to get out on the bank on wet nights. It was actually raining earlier today. I wish it was still a little wetter. On a wet night like this, you might see Rivulus just dancing around on the rocks, looking for side pools, looking to get around barriers, whatever. So what you find in Trinidad is that Rivulus is pretty much a ubiquitous feature of headwaters. And they achieve these really high densities dominated by large, slow-growing adults, probably limited by intraspecific competition. Now, the way we catch these fish is using these handy-dandy dip nets. And I'm going to attempt to catch one in real time. Wish me luck. Show you how we do it. Earn my salary here. Okay, let's see. So here's a small Rivulus in the water. I've got it directly in my headlamp. And all we do is we try to coax them into our dip nets. Now, you might say that guppies have one move. Rivulus have about two moves. And so you have to think a little bit ahead of them. Am I going to get lucky this time? Yes, I did. All right, so there you go. That's the little Rivulus. As I said, they're a killifish. This one's a male, which we get from the tail, which is black with some yellow on it. And you might also be able to see an orange mark along its anal fin. Anyway, so what we do is, Rivulus are a little hardier than guppies. You just take the fish, goes in a Ziploc, and that's part of the sample. We'll take that home, and I'll go ahead and turn off my headlamp again. And we're going to give it an individual tattoo the same way we do with the guppies, and then release it again after collecting, length, weight, the usual stuff. And in that way, we'll be able to estimate population size, size structure of the population, individual growth and movement, all of which could be affected by the intrusion, the invasion, the introduction of the guppies that we're going to do, that we have done downstream. We're up here in the control reach, which provides us spatial control. If something happens that is in both the introduction and control, for example, if the population drops in both, that wouldn't be evidence of a guppy effect. That would just be something related to climate, unless you want to say that guppies affect the climate, but that's maybe a bridge too far. We also have a different kind of control, which is we were sampling in the introduction reach before the guppies were introduced, so we also have a before-after comparison for the introduction reach. Altogether, it's called a Bakke design, before-after control impact. And the idea is, by having those two types of controls, both temporal and spatial, and then replicated across 4 rivers, that we see a consistent pattern, or at least see the important patterns anyway, of the signature of the guppy introduction. Now, that doesn't necessarily get you to mechanism. That's more of a mesocosm thing that I believe David's talked about already. Now, what kind of effects could be happening? Well, these Rivulus, and I'll go ahead and, so this is a good example of a slightly overpacked bag, but these guys are generalist predators. Gape limited is what we like to call them. When they're young, like, let's see, let me see if I can. This one doesn't have a really young one, but young ones are more on aquatic prey, like mayflies and caddisflies and chironomids, which gives them a big diet overlap with guppies. And then the adults, as they get larger, become more interested. They're able to capture larger prey, and also tend to shift somewhat anyway toward terrestrial prey. like crickets or ants or wasps, that sort of thing that might fall into the river. So since there's a diet overlap and there's some habitat overlap, rivulus and guppies both like these pools like this. This pool, for example, probably has 60 rivulus in it right now. So there's a potential for big overlap, but given that they're active at different times of day, we're out here at night with the rivulus when they're awake, and the guppy folks obviously sample in the daytime when the guppies are awake. It's possible that they don't interact all that much. It's much like workers on different shifts in a factory. But that's not what we see in nature. Trinidad has a number of barrier waterfalls, actually like we have downstream here, that don't allow guppies over, but rivulus are able to get over because of that dispersal ability I was talking about. And so if you sample the pools above and the pools below the waterfalls, you'll find that the rivulus-only area has a density of rivulus about 3 times greater than you have just below the waterfall, which has the guppies, which is a pretty strong evidence, at least it's a correlation, that suggests that guppies have a pretty strong negative impact on rivulus. Now, whether that's a competitive effect or a predation effect of guppies on juvenile rivulus is one of the things that we're trying to work out as part of this project. And that is about what I have to say, and I hope to talk to you all some more later. Bye.